Good afternoon, everyone. So, today we are going to discuss the topic wherein we are going to find a shortcut to find the magnetic moment, spin only magnetic moment. This is one of the important questions that come for IIT JEE, JAM, and even CSER NET examination. And this combined with some coordination chemistry question comes for higher examination. But IIT JEE, we can see that this questions directly come. That is, you have to find the configuration or the electronic configuration from the magnetic moment or the magnetic moment from the electronic configuration. These questions are usually asked. So first of all, I will be telling you what the formula is, and then the normal method that we adopt to solve the question, and then I will be mentioning the shortcut that I have found for you. Okay. So see, here the magnetic moment of a d block element can be found out by spin only formula. That is, in the transition series, we can find the magnetic moment using uh, spin only formula. What is the spin only formula? Spin only formula is this one, that is mu. Mu stands for the magnetic moment, is equal to root of n into n plus 2. Here n is the number of unpaired electrons. Now, if n is equal to 0, what does n equal to 0 means? If n is equal to 0, then there is no unpaired electrons. In that case, this is called a diamagnetic compound or species, diamagnetic species. If n is not equal to 0, what is the meaning? The meaning is that there is some unpaired electron or electrons. So, that will be called as paramagnetic. This is the basic thing we need to know. Now, how to solve a question in this part? I will tell you that. Now, let us look at this question. Suppose we are asked a question to find the magnetic moment of Mn2+, that is manganese 2 plus iron. What is manganese? The electronic configuration of manganese. It is 3d5 4s2. Mn2 plus therefore will be 3d5. The next step what we are doing, we will be writing the configuration, and we can see that all these are unpaired electrons. We don't have any paired electron, and as a result n will be equal to 5 since all are unpaired. Now what is the type of species? Is it paramagnetic or diamagnetic? From here we can see it is not equal to 0, so this is a paramagnetic species. In the next step we are going to substitute it in the equation, and we will get mu equal to root of 5 into 5 plus 2, root of 5 into 7 is equal to root 35, and then we are writing it as 5.92, and then we will be checking the options, and we will be finding that A is the correct. So here we are actually doing 1, 2, 3, 4, 5 and 6 steps, but I can now reduce this into just 3 steps. That is the trick in this portion. So, listen carefully. The trick here is that if n is equal to 2, then mu will be approximately equal to 3. If n is equal to 3, mu will be approximately equal to 4. If n is equal to 4, mu is approximately equal to 5. And n is equal to 5 means mu is approximately equal to 6. You can directly find that this shortcut is true from the question that is already given. See, here we actually did all these steps, but if we know this trick, the only thing that we have to do is to find the number of unpaired electrons. In the second step itself, we know that the number of unpaired electrons is 5. So according to our shortcut, when n is equal to 5, we should actually get a magnetic moment value that is close to 6. So in this option, the option that is closest to 6 is A, that is 5.92, and that will be our answer. So this shortcut fails only in the case when we are having closely related options. That is, if 5.92, 5.8, like that options are given, only in that case we have to do the calculation. Most of the times such questions do not come, or such options do not come. We will be always having options of this form, and we can save almost 1 or 2 minutes in the examination if we skip the calculation. And you know how much time it is 1 or 2 minutes can give you an extra time to attempt 2 or 3 more questions. Now we will check your previous question from this part and solve this within seconds. Okay. Now this is a question asked in JEE 2011 examination. So the question is to find the spin-only magnetic moment of NaCl4 2 minus. So let us see whether we can do this question by the shortcut that we have studied just now. What is we are having the species NaCl4 2 minus. So the oxidation state of Ni will be, consider it as X, then X minus 4 will be equal to minus 2 and X will be plus 2. Therefore, Ni will be in the plus 2 state. So nickel usually is 3D8 4s2. So Ni 2 plus will be 3D8. In the next step, we will be drawing the configuration, and chlorine is a weak field ligand, so there is no pairing. I will be taking the splitting of d orbital strong and weak field ligands in the next video. For right now, for the time being, you should know that weak ligand, no pairing. So what will be the case here? It will be 1, 2, 3, 4, 5, 6, 7 and 8. So how many unpaired electrons are there? We are having 2 unpaired electrons. Now our usual step will be writing root of 2 into 2 plus 2, then finding root 8 and then writing the answer. But what we have already studied, if n is equal to 2, mu will be approximately equal to 3. So what is the option that is closest to 3 in here? That is A, 2.82. Now if you calculate root 8, that answer also will be approximately equal to 2.82. So without calculating, by finding just the number of unpaired electrons, we are able to calculate the magnetic moment. More questions of this part will be solved in the next video after I take the d orbital splitting, weak field and strong field ligand. So hope you all understood the shortcut and try to solve questions from this part from your previous year question papers. And if you have any doubt, please ask below in the comment section. Keep watching, subscribe our channel and do ask any doubt you have. Thank you.